Understanding the order of recursive calls is important in understanding the behavior of recursive functions. And the thing to remember is that when you make a function call, you have to wait for it to return before you can do anything else. So if one function calls another function and then does something after that, that function call has to return before whatever else happens next. Let me illustrate what I mean with the cascade function. The cascade function takes in a positive integer n. If n is less than 10, it just prints out n. Otherwise, it first prints n, then makes a recursive call to cascade on a smaller number that's everything except for the last digit of n, or n divided by 10, with the remainder thrown away. And finally, after that recursive call to cascade, it prints n again. Let's take a look at the behavior of this function. So if I cascade just the number 5, that's the base case, and I print out the number 5. But if I cascade 1, 2, 3, 4, 5, then I see this beautiful design where 1, 2, 3, 4, 5 is printed. And then we see a cascade of smaller versions of that. And by the way, the original number is printed again at the very end. Now the first and the last lines all come from this print statement. And in fact, most of the lines that you see here come from either this print statement or this print statement. Only the base case, which is for the number 1, comes from this print statement. What this is supposed to illustrate is that all the cascading that happens recursively happens before the final print. And that's why you get this nice nested structure. Let's take a look at the environment diagram so that we can see exactly what's happening. So we defined cascade and then call it on 1, 2, 3. The original call checks for the base case, doesn't find it, and so prints out 1, 2, 3. In the Python tutor, you can see that the program output generated so far is just the number 1, 2, 3. We still have to generate all the rest. And how do we generate everything smaller than 1, 2, 3? Well, that involves a recursive call to cascade, in this case, where we've thrown away the last digit and we're left with just 1, 2. So the important thing is that this call to cascade will complete before we ever go back and finish the original one. So what do I mean by complete? Well, it's going to print 12, make a recursive call on n equals 1, which is the base case, which gets printed out. So now we've cascaded all the way down. How is it that we cascade all the way back up? Well, our third call to cascade returns. What does it return? None. Why? Because there's no return statement at all. And if, when executing the body of a function, you reach the end of the body without ever seeing a return statement, you always return none. Okay, now we have to ask ourselves, where do we return to? Well, we were in the middle of this call to cascade, which involved this line. Finally, we figured out that that had a value of none, and then we go on and finish printing n is 12, right there. And when we print that, we actually see that 12 appear, and we have a return value of none from this call, which means that we can finally return to our original call to cascade and finish up. So we've evaluated this, and in the course of evaluating that, we generated all this output, and finally we're going to print n at the very end. And now we're done. Okay, so a critical moment in the environment diagram was when we had returned from the second call to cascade, but we hadn't yet finished the first call. So the first call had printed n, it had cascaded all the way down to get 12, 1, and 12, but it hadn't printed n yet, and that's the very last step of cascade. So each cascade frame comes from a different call to cascade, and until the return value appears, that call has not yet completed. And so, any work that happens after that call hasn't happened yet. Any statement can appear before or after a recursive call. There's the one before, and there's the one after. It was the third call to cascade that printed out the number 1. It was the second call to cascade that printed out both of those 12s, one before and one after printing the number 1. And finally, this first call printed the 1, 2, 3 and is about to print 1, 2, 3 at the very end. Now that's not the only way to define cascade. An even shorter version would say, well, in the base case or in the recursive case, I always print n first. So why not just put that at the very top? And then there's actually nothing left to do in the base case. So I could just change this if statement to be all about the recursive case, which is when n is greater than 10. I will cascade and then print again. So now if I cascade 1, 2, 3, 4, 5, it still works. And I have a slightly shorter function definition. By the way, this works even if I add more numbers, and it only becomes more beautiful. But which version of cascade is better? So we have one that breaks out the base case and the recursive case and tells you what to do in each. We have this other one that finds what's similar between the two and tries not to repeat itself. The two implementations are equally clear, then I think it's usually better to prefer the shorter one, just because it takes other people less time to read it. In this case, the longer implementation is more clear, at least to me, because it clearly breaks out what's the base case and what's the recursive case in that order. And that's the way I'm used to reading recursive functions. So when learning to write recursive functions, I recommend doing that as well, but you don't have to. But both of these are recursive functions, even if only the one on the left has a typical structure. If you're trying to choose between one and the other, remember that when you write programs, they should be written for somebody else to read, and only incidentally for a computer to execute them. So, think about which one you'd like to read if you were reading somebody else's program, and make your choice there.